Question number 7 is a normal distribution sum. It is mentioned here. It's a normal distribution sum. So a manufacturer fills jars with coffee. The weight of coffee, W grams, in a jar can be modeled by a normal distribution with mean 232 grams and standard deviation 5 gram. Remember, standard deviation is sigma, mean is mu, and normal distribution is written. First you write a random variable. In this case it's W. Then you give this symbol, then you write normal distribution, you write mean and variance. Now the information that is given is standard deviation, which is sigma. So variance is sigma squared and mean is mu. So let's get started. So the random variable is W, they're mentioning it. So this is 232 grams and this is sigma squared variance. So the first question is W is less than 224. This is a type 1 sum where you find the probability. So probability of W is less than 224 grams. The first thing that you do in a normal distribution is to make it unit free. And to make it unit free, you have to do the Z score or Z score. Z is less than 224 minus mean 232 divided by the sigma 5. So this is the Z score formula. Let me write it out here. Z equals to random variable minus mean divided by sigma. This is the Z score to make it unit free. Okay, so this is probability of Z is less than minus 1.6. So we make it positive by reversing this because it is continuous. It makes no difference whether it's less than or equal to. So we just reverse this and it becomes positive. And in order to make it less than, because in the table we have to make it less than, it means 1 minus Z is less than 1.6. So let's bring out the table. So here we are looking for 1.6. So this is the Z and this is the probability. So 1.6 is here. 1.60, it is 0.9452. 0.9452. So if you subtract it, 0.0548. So question number B. Question number B, you have to find the random variable. Remember, whenever you have to find the mu or the sigma, meaning mean or standard deviation, or the random variable, it is called a type 2 sum. So you do the type 2 sum in the same way as you do type 1, where you find the probability. This is a small letter W and this is a capital letter W, and the probability is given in point 2. In a type 2 sum, the probability is given and you have to find the random variable. So let's do the Z score first. So this would be 232 minus mu is also 232 and standard deviation is 5. Now it becomes Z. So W minus 232 divided by 5 equals to 0.2. So this becomes 0 and this becomes W minus 232 divided by 5 equals to 0.2. Now always draw a miniature picture here of a standard normal distribution. Remember, a standard normal distribution is something that is unit free, and Z is the normal distribution random variable, mean is 0 and sigma is 1, so sigma square is 1 square. So you sketch it. So this is 0. So if you start sketching it from between 0 to this side and you want 20%, 0.2 means 20%. So 0 to somewhere around here, this is positive, so this is going to be 20%. So 0 to A, this is 20%. So that means let this W minus 232 by 5 be equals to A. Always use a substitution and always use an alphabet, whether it's positive, if it's before 0 it should be negative, to do this type 2 sum. So we can write between 0 to A equals to 0.2, and this becomes probability of Z is less than A minus the previous one, probability of Z is less than 0 equals to 0.2. So probability of Z is less than 0 is going to be 0.5. So that means 0.2. So we get probability of Z is less than A equals to 0.5 plus 0.2 is 0.7. Now remember one thing, this is a type 2 sum. What I mean by type 2 sum is where the probability is given and you have to find the random variable or the mean or the standard deviation. For this they have a special table. This special table is the next table. the table on the next page in your formula booklet. The specialty of this table is that the probability is given here instead of z, and from the probability you have to find the value of z. And most of the cases you have to use this table, so always start with this table. If you use the other table, you're going to lose the accuracy mark, because this is around 4 decimal places and the other table is only 2 decimal places. For example, when you have a probability of, suppose, 0.3, 0.000 doesn't really matter, 0.3, it is 0.55244. so if you look the other table where you have probability, here this is the probability, so you're looking for a probability of 0.3, so you don't have a probability of 0.3. so what do? So even if you had, suppose you have a probability of 0.7, if you had 0.7, you would be looking for something like this, 0.52 or 0.53. so this is one thing. Another thing is that this table where you have to have z is greater than, so for the type 2 sum where the probability is given and you have to find the mean or variance or any random variable, you have to remember it has to be greater than. So let's get back to the sum. So we want to use the other table and it has to be greater than, so this is less than. So let's make it greater than. Whenever we do 1 minus, it becomes greater than. Therefore 1 minus 0.7, probability of z is greater than a. Therefore probability of z is greater than a equals to 0.3. so we can easily now use this table. So 0.3 means 0.5244. So a equals to 0.5244. So w minus 232 by 5 equals to 0.5244. Therefore a little arithmetic would give you w equals to 234.622. So that is the value of w. Now I have to stress that the same sum can be done without this table. Without this table, you can use this table from this line where you have less than. So you have less than, z is less than 7. So if you look for 0.7 on the other table, so you will see that 0.7 is somewhere around here. This is 19 more than 0.7, 0.0019 more, and this is 15 more, so this is closer. So this is 0.52. But if you take a look at a from the other value, you will see that it is 0.5244. so this is more accurately. So please always, for type 2 sums, for random variable, mean or variance, use this other table. Question number C is not a normal distribution regular sum. It's something to do with basic probability. So this sum can be done. There are 2 jars and you have to only one. You have to take only one, and they have to be between 232 grams and w grams, which is exactly as this. This thing, and this thing is exactly the same. So you can say that the probability of that between 232 and w is 0.2. So out of 2 jars, you need only 1 jar. So it could be probability of only 1 jar. That can mean yes, meaning 1 jar out of 2, or the second one is yes. So you can write 0.2 is the probability of yes, of having 1 jar, into probability of not having 1 jar is 1 minus 0.2, or 1 minus 0.2, which is no, into 0.2, which gives a probability of 0.32. Now the same sum can be done using the binomial theorem, which says, so alternate method, which is more common in S2 sums. The binomial theorem says that 2 choose 1 and 1 minus, probability of this is 0.2, 1 minus 0.2 to the power 2 minus 1, and 0.2 to the power 1. This will also give you 0.32. This is not a regular normal distribution sum. Okay, this is general discrete distribution. So let's start. We have the discrete random variable x can take only values 2, 3, 4 or 6. For these values, the probability distribution function is given by this. So find the constant and show that k equals to 1. So all you have to do is add up all the probability and show that the total probability is 1. So 5 by 21 plus twice k by 21 plus 7 by 21 plus k by 21, total probability is 1. So if we add it up, all of it, so we get 12 plus 3k by 21 equals to 1. So we get 12 plus 3k equals to 21. We get 3k equals to 9, therefore k equals to 3. In question number B, we have to find f3. f3 is probability of x is less than or equal to 3. So probability of less than or equals to 3, that means 3 and 2, 5 by 12 plus 2k by 12. Probability of 2 plus probability of 3, that is 5 by 21 plus 2k by 21. That means 5 by 21 plus 2k is 3, 6 by 21. That makes it 6 plus 5, 11 by 21. Question number C is find the expected value. So expected value is random variable into probability. So 2 into 5 by 21, 3 into 2 by 21. So 2 into 5 by 21 plus 3 into 2k into 21 plus 4 into 7 by 21, 7 by 21 plus 6 into k by 21, k by 21. So if you add all up and if you put the value of k equals to 3, you're supposed to get 74 by 21. So you have to do the arithmetic. The next question is find ex squared. Ex squared. So ex squared is similar to ex. So this is random variable square into probability plus random variable squared into probability plus random variable squared into probability plus random variable squared into probability. So let me check. So all these things and you add it up, put the value of k equals to 3 and you get 14. Now question number E is find the coding of this variance. So we know before that we need to find the variance. So variance is ex squared minus mu squared, which is 74 by 21 whole squared, and that gives the variance 698 by 441. Therefore the coding of variance of 7x minus 5 is going to be 7 square into variance of x. This thing disappears. So 7 square is 49 into the variance is 698 into 441, and the answer is, so it is 698 by 9. So this is a pretty straightforward sum.